All right. Miss Stone here. This is for grade 12 University Prep Physics. Very short little lesson on polarization. This does need to go hand in hand with my 3D glasses. So, yeah, in class one day this week, we'll definitely get the 3D glasses out because it won't blow your mind, but it's still better than not using them. Anyway. So what this lesson is about, it's very short, just on the concept, no math, concept of polarization, and that it is evidence that light does travel as a transverse wave. And what it means is, I don't know if you've ever heard of Polaroid filters. You know, it's a certainly in cameras use them, and I do have some camera lenses, and then of course 3D glasses are polarized. But it's really a kind of simple concept. It's just this idea when you hear polarization, or there's sunglasses that are polarized, and they reduce glare because they only allow what a polarized, what do I want to say, polarized lens does, or whatever, is it only allows light of one way, of not one wavelength, but of one orientation to pass through. And light travels in 3 dimensions. So like it would come in, and this is what we call an unpolarized beam of light, so just a like wavelength, and it would travel in the electric and magnetic fields, sort of travel at right angles to each other, but it could be sort of angled on any angle, right? It could be on any sort of orientation possible. What happens here, it is really just like a grate with all the lines in one direction, and all that can come through is the light that's vertically polarized, right? That's just straight up and down. And then if this light then hits a polarizer that's in this orientation, nothing comes out. So you can completely block light, and this is, we can see this with the 3D lenses, right? That, you know, you turn them at right angles to each other, and you can make it so that nothing comes through at all, which is kind of neat. And so sunglasses are often polarized because what this eliminates is any glare whatsoever. Because a glare, of course, is something reflected in light shining in all directions, kind of like light out of a diamond, right? But, oh, Charlie's barking. Oh, we'll just ignore him. Okay. Oh, yeah, so here we are. So imagine a polarized filter is a picket fence, right? And only light that's going in one direction can make it through. There's just no way that if light was going side to side like this, it would make it through the fence, okay? And so when we talk polarization, that's all it is. It's should be fairly easy to understand. Of course, we see polarized sunglasses, and this is just showing, you know, you've got light in all, sort of in all directions, and when it comes through, you know, all the glare is reduced because light's only traveling in one direction, so it's not shining in every way. On a lens on your camera, right? Whoopsie. Light lens like camera, you take a photo with a polarized lens, right? All this back glare coming off the car, it's not there. Only light that's going one direction, which is just the blue, comes through. And it's not all interfering with each other like the white light would be. That's what white light would be, right? Light interfering with each other. Yeah, this is an interesting thing. I have a pretty tough clicker quiz on this. It'll probably just irritate you, but it's also kind of interesting. Particles of light are called photons, as we know. And while it's true that the light's coming through as a wave, right? What happens is that a light, you know, it's also particles. So it only lets about half of the particles through. So any particles that are rotating in the horizontal plane won't get through this particular lens. And it's kind of gets interesting when you think about vertical and horizontal components. So, you know, because take this piece right here, okay, that part of that wave in that orientation. Well, that's partially vertical and partially horizontal. So the partial part that's vertical will make it through. And that's why half of the photons make it through. Because actually, if you look at this and you see that light could be traveling on a million different planes, I mean, like truly infinite, it could be, you know, more than 360 sort of degrees of the you know, could be on any angle possible. You'd think, well, if this is only letting it go through that's vertical, it should be less than half, right? Only a small fraction. But it's like all the components of the light that are in the up-down direction make it through. And that's why exactly half the photons would make it through. So half the photons that hit this filter get through the other side. And then if this one's orientated in this direction, then 0 of the photons will make it here. Yeah. And this is what I was telling you earlier, that, you know, we can't really, nothing really comes through if you have them in 90 degrees. And you'll see this. We'll do this in class. If you, might be easiest if you remind me, once you watch this video, tell me, and I'll get you the things, and then you're ready to try it. So yeah, this is the summary. This is about all you really need to know about polarization, I mean, as far as we're concerned in grade 12 physics. If you have a polarized filter, you can get, one of them will let about half the light through, and two if rotated at 90 degrees. Because if you had 2 polarized filters, but they're just orientated the same way, well, it'd be the same as just having one. Because if they're orientated the same way, they'll still, the same light that made it through the first one will make it through. But if you turn that second one 90 degrees, nothing comes through. And I'll let you play with that in class because it's fun. And that's it. We'll talk about electromagnetic spectrum in our final lesson of this unit. Oh, I lost my thing. There we go.